What I'd like to present today is a technology approach born of a public-private partnership that can accelerate that distribution and transform education in the developing world, and particularly in rural Africa. A self-contained solar container classroom, mass-produced in cities, with solar pre-assembled on the roofs, and equipped with hand-picked ICT components purchased in volume, and with a standardized floor plan that enables teacher training to be scalable and easier to implement. Now, countries we work with, from Sierra Leone to Uganda, want ICT labs, but it's not as simple as just dropping in computers and expecting transformation. First, there's the immediate lack of power, and if there is grid power, it's unreliable, and that means we need UPS systems for every computers, and those UPS systems aren't designed to be used every day, and so they fail at great cost. And then we have teacher training. The students always race ahead of the teachers, so how do we get the teachers in front of this brave new technology? And we have the challenge of the existing infrastructure, drab rectangular buildings that aren't conducive to a creative learning environment. And we take internet for granted, but many of the places we work in have at best a 3G connection, or they require expensive satellites. So how do we make offline computers relevant? And we need to start thinking of computers not as systems unto themselves and computer labs for the sake of it, but as learning appliances and tools. So when we do healthcare projects in Nigeria, the computers we make are tools for patient registration, for treatment, for diagnosis, and for telemedicine. In an education environment, they should be learning appliances. Simple, easy to use, robust devices, loaded with software that's accessible and that teachers can get involved in. And so this is an example. We did a project in rural Ethiopia based on the hole-in-the-wall endeavor, so a single computer and solar panel. And the chemistry teacher at that rural school had no periodic table, handwritten or otherwise. But with a lightweight solar computer running free open source software, in this case Calcium, they had an interactive periodic table with 3D molecular models. So that's one example of content that can leapfrog. We can also use computers to enable distance learning, which I'll talk about more later. But that can supplement existing schools and so reduce classroom congestion. Now let me give you a little bit of background on how we came about with this solution. So I spent a week volunteering in Ghana, and my former managing director had donated $20,000 through his church to a local charity. And they wanted to build an ICT access suite for street children. And so I flew down to Ghana, and to keep within the budget, we bought 3-year-old secondhand traditional desktops. And because they were old, they were prone to failure, and they consumed inordinate amounts of power, which meant we needed large, expensive UPS systems. And even though there was incredible excitement and anticipation from the children, the project ultimately foundered because there wasn't the budget allocated for the ongoing costs, which crippled it. And for me, internet is like oxygen. I depend on it. But the first thing I wanted to do was show these kids, all of whom thought that any familiarity with a computer would equate to an economic advantage. And the first thing I wanted to do was show them Google Earth. But how do you do that if you have a modem speed connection that's shared over 20 computers? And so I set out to do this better. How could you develop fit-for-purpose hardware? And in 2007, we released our first computer. Because fans in computers suck in dust, and that causes failures, we use low-voltage laptop components that produce less heat. And instead of using plastic cases, we made the chassis from a single block of aluminum. So the case would serve as a heat sink, the computer inside would stay cool, and we wouldn't have the issues with dust. And because we wanted to use these computers in remote areas, we wanted to minimize supports, we got rid of hard drives, and we embraced the new technology, solid-state drives, the same NAND technology you have in your iPads. And we didn't need 500 gigs. We could get by with a little bit of storage for a local OS. And we wanted to use these in remote areas, so we needed energy efficiency. Now, any computer can run on solar, but the problem is a traditional desktop is designed for value and performance, and it's not designed for energy efficiency. So your solar cost will be 4 times the cost of the PC. But if we can start with an energy-efficient computer, we can make the solar affordable. And initially, we worked with a network of solar partners. And so we were able to go into rural areas and replace the default off-grid power source, which is a cheap Chinese petrol generator, with clean renewable energy. And that was fine in Uganda, where we had a large network of suppliers. But in Angola, we had no credible solar partner. And so we had to become experts in solar. And what we found is it's very difficult. So the PV panels you see there are now commoditized and very low cost. And for sites like that in the UK where you have 20,000 panels, that's fine. But the thing is, the output rating on solar panels is based on lab conditions of 25 degrees. And if your ambient temperature is 35 degrees and you're on the equator during the midday sun, those black silicon cells will be 80 or 90 degrees. You can fry an egg on them. And that means your voltage drops massively. And then you have the batteries, which need to be ventilated because they emit noxious gases. And you've got expensive cabling, and you've got charge controllers, which you need to hand pick for quality. And the biggest problem is almost all solar installations convert to AC, which is inefficient, produces a lot of heat, so you have fans, and you have a single point of failure. So it's tricky. And we still persevered, and we developed a solar classroom-in-a-box solution to take some of the guesswork out of this. So we could hand-pick the components. We could buy them through European channels, so we wouldn't have to worry about grade B solar panels that we find in Africa or counterfeit batteries that we found in Nigeria. And this is a project we did in Naivasha, a beautiful part of Kenya, 3 hours from the capital. It's where most of Europe's roses and flowers come from. And it's an interesting project because the funds for this came not from the UN or from international aid, but from local fundraising efforts. So Kenton College, an elite prep school in Nairobi, had a wonderful idea of parents sponsoring their children to not watch TV for a month. And that was effective enough across a large school that they raised the money for this. And the building you see there, this concrete structure, it only cost us $7,000 because we were close to Nairobi. Now that we're working in Dadaab in the north, the building costs are 3 or 4 times that because the local contractors are a monopoly and the transportation costs and therefore the material costs are much higher. Now we planned as much of this as possible in advance. We loaded the computers into these wall-mountable cabinets, we cherry-picked the batteries, but we needed a second pickup truck to bring a diesel generator because we had to have welding equipment on site so we could weld frames for the panels, and that meant we had to do a site survey in advance. And what we find time and again is the roof is facing the wrong direction, or it's not structurally strong enough, or the angle's not right, and this really matters with solar. And what ends up happening is you have to create a separate solar array with concrete foundations, and suddenly retrofitting solar becomes very expensive. Now with this project, we had the site survey, so we didn't need to chop a tree down. Luckily, we didn't need to reinforce the roof, and we were able to install the solar, even though it was time and sort of admin intensive. And we put these computers in, and it's typical of the projects we work on. This is what gets us out of bed in the morning, is that 10 computers were used by 628 boys and girls, and for every single one of them, it was their first time using a computer. And for someone like myself, it was fascinating to watch how a young student interacts in that environment. So they were nervous just touching the mouse. And we can teach computer literacy and we can teach computer proficiency, but first we were teaching computer confidence. Just getting people comfortable with this new technology. And of course that needed to be teacher-led. And so we spent time with the teachers early on. We showed them typing games, which were valuable to them. We got them trained up on Open Office. And then we opened it up so they could manage the classroom effectively. And the schools split it so that every student did get access, and every year another 50 students get access. And this is a way for a little bit of hardware to have a lot of impact, which is what excites us. But we were still hamstrung by the building. So not only was it expensive to retrofit, but it had a drab interior. And this is another classroom we did in rural Zambia, so typical concrete floor. The PCs are all mounted against the wall, and it's more of an internet cafe than a meaningful, quality ICT experience. And so we thought, instead of building a better computer, could we build a better classroom? And so we reached out to our network, and the University of Edinburgh School of Architecture loved the idea. They gave us 8 design students pro bono for the better part of a year, and we worked with Learning Planet, a nonprofit customer of ours in Nepal that builds schools from local sustainable materials. And so this is a before and after shot, mud and wattle classroom, transformed with a bit of paint and genius into a creative learning environment where a teacher can circulate around. Now, it was very important to us that if we did this, it should be mass-produced and scalable. And there's nothing really more mass-produced than a 40-foot steel container. So this has a lot of benefits. It's very cheap, $2,000 to free. It's robust and weatherproof. The problem is it's an oven. So if it's 35 degrees outside, it'll be nearly 50 degrees inside with the doors closed, and that's if it's painted white. And so how can we make that effective without relying on air conditioning, which would use too much solar power? So we look to design influences such as this, so using natural materials to provide insulation, which could be locally sourced. And what we're really trying to do here is create a model. Now, we'll give away the blueprints, but we want large industrial construction firms in the cities, and particularly in the ports. Now, a number of the places we work, Temagana, Port Harcourt, Nigeria, Mombasa, Luanda in Angola, because of the trade deficit with China, there are surplus containers. The structure itself is practically free. And there's the industrial capacity in the city to do the welding, to create the windows, to pre-make it, and then we can roll it out to rural areas, and all we should really need is the land. And this has been, as you can see, these are architecture renders. This has been an academic exercise, but I'm glad to say we've finally had sort of vindication, and we're now launching 5 of these centers in Oyo State, where we've also been doing prefabricated clinics. So this has been tried before. You just have to Google container architecture, but as you can see from these steel and glass structures, it's been limited to designer homes and espresso bars, with the exception of this creative school in South Africa, which had a wonderful playground and a canopy roof, but as you can see, it's only 8.5 feet wide. And so without computers and with small 7-year-old students, it's still quite narrow and restrictive. And then we looked at ICT attempts. So this is one with that Dell did in Lagos as a pilot. But as you can see with those wall-mounted computers and those students squeezed in, it's really hard for a teacher to manage this kind of classroom, especially if the students and the teacher are using computers for the first time. So we wanted to keep the container model because we can transport it easily on a standard truck, but we need to expand it. And so what the team came up with is we dropped the wall down, and we removed the roof, we replaced it with low-cost steel pipes, put a corrugated tin roof in. Now that opens it up for better ventilation. It also gives us twice as much space for solar panels. And the solar is the inexpensive part, the batteries are the expensive part. Now we don't need to have that solar array. And this is a model where we've taken 2 20-foot containers. Now we did this for areas where we can't get a 40-foot container because of the roads. And we've done the same thing of knocking down the walls and creating a hardwood floor courtyard with the building clad in bamboo. Now bamboo is a natural insulator. That means we don't need air conditioning. And the great thing about it is you can grow a bamboo garden next door, so you can top up your building materials and repair it. And we fill it up with mosquito nets. We put the windows in the right place to encourage airflow. Now, it's not as cold as this room. We're still talking 26, 27 degrees, but we can get by with a few fans. And more importantly, in the evening, because we have this solar power and we're using low voltage LED lights, we can open it up to the community. And we've done this in the Nigerian Delta, where we did a hybrid project with the federal government, and it was an ICT classroom by day, and in the evening it was opened up to the communities. So people could go in, access the internet, watch football games sometimes, and also get training on things like agriculture and husbandry. And so as long as you have the solar, you can keep those computers and those LED lights running, and this provides the infrastructure. It also enables us to have a lot more control over the implementation of technology. Now, this photo is typical, so you try to drop in a whiteboard, but it doesn't work because the wall can't support the mounting of it, and there's too much light pollution for the projector. We don't have the luxury of ultra short throw projectors because we need to use LED technology. We can't use that much power. So by having it in a centralized container classroom, we can put the wall there in advance, and we can manage the projector position. We don't have to worry about whether there's a rafter or a beam that will support that projector. So all of this stuff can be more intelligently sorted in advance. And because we have twice the floor space, we can have a more flexible layout. So it might be hard to see from the architectural drawings here, but what we've got are all-in-one computers and monitor arms, which are on desks, which have casters. And so in the evening, those are moved into the side. There's a secure shed with a metal door, and we can have a very flexible layout and work towards this pod arrangement, which is now very popular in the UK and the West, this island-style computer lab where the teacher can circulate. And we can open it to the community. So we can wheel those computers out of the way, distribute $5 stackable plastic chairs, and have a really meaningful community center. Now, because these areas are sometimes offline, we got to think about the content we can load. So Khan Academy, TED Talks, so those are obvious, what you might not know is that Wikipedia, though it's hard to rebuild offline, you can get all 4.4 million English language articles into a 2 terabyte disk drive, and we can put that on a lightweight local server, and anyone can access it, be it on a tablet or on a desktop computer. Yoruba, the language of Southwest Nigeria, is only 20,000 articles, so you can fit that on a thumb drive. So we can load that content in advance, taxing the network less, and also enabling a resource for teachers so that we can have more kind of buy-in and engagement from teachers. Now, this is content consumption models, and what really excites us about the possibility of a lab is content creation. So can students use these large displays and these full-size keyboards to not only write documents, but to code or to develop Android apps and to provide meaningful ICT capacity. And one project we're particularly proud of, and this is an example of computers as tools, is a distance learning initiative. So we did this actually with GEMS in Ghana. We have 140 classrooms in the Kwanta South in the north and western Ghana and Dogme East, all very rural. And what we provided was a micro solar solution, a rugged PC, an LED projector, and a satellite connection. And what we're trying to do here is provide better education and also to free teachers up. So we can have, instead of a trained teacher managing the classroom, we can have a sort of junior technician who manages it. And we have a charismatic, expert teacher in the capital. And we are changing the model of education. So instead of it being 55 minutes of rote learning, the teacher can provide 10 minutes of science or math lecture and break into activities. Now, the thing is, distance learning and MOOCs are great if you have a high-speed internet connection, but we don't have that here. And the satellite internet connections that ships use, those cost $3,000 a month. So what we did here was we created a private, or I should say GEMS did, is we created a private TV network. So we actually beam down content that's crisp and sharp, but to make it interactive, unlike a MOOC, we have a slow uplink, but it's fast enough that a student can ask a question into a microphone. And so the teacher can do 10 minutes, and then she can serve 20 classrooms or 800 students at once, and they can ask questions. And that's very powerful, but I think what's equally impressive is that we can bring in role models. We can bring in business mentors, we can bring in politicians, and one of the early speakers was Ghana's only female pilot. So she can come in, she can speak to all 140, tens of thousands of young women at once, and rather than 140 people clamoring for the microphone, it's run like a talk show. People can instant message in questions. There's a moderator in the studio in Accra, and they can say, Abigail from Dogme East, has this question. So, these are models where we can go beyond just PC labs for the sake of it and try to transform technology. And I come from a hardware and solar background. There's a lot of people much smarter than me in this room, and what I'd really like to gain insight from is if we can provide this delivery vehicle, if we can ensure uptime of the computers, the reliable functioning of the computers, provide the ICT access, how we can leverage that. And I'd love to hear any questions or thoughts.
Would anyone like to ask Mike? Okay, Mike, just stay there just a minute.
Sure.
I think what's impressed me most, is the fact that Mike is a lateral thinker. You and your company are not prepared to accept the normal design solutions. Often companies will put barriers in the way, say, no, it can't be done, can't be done. This man won't accept this. And as a result, what we've got children in a developing world who can now access similar opportunities to their peers in a developed world. I think that is quite remarkable. Well done. Thank you, Mike.
Thank you.
Thank you, Irene. Okay, I think we finished slightly early, actually, after all that. So,
more questions?
Any questions? Would people like just to chat to Mike or Irene afterwards? Yes, of course.
Okay.
Absolutely.
Thank you.
Yeah. Okay.
Just one.
Yeah, of course.
Mike, any role for tablets here?
Yeah, actually, so it's something we're really interested in. And so, tablets use very little power. It's easier for us to put a bank of USB ports. And one of the models we're really sort of leaning towards is that you go in and you create content on the desktop model, and then you bring in a tablet. Now, iPads are too expensive, but low-cost Android, sub-$100 tablets, you can bring those in, you can charge them during class time hours, and you can have an offline access point. So, TED Talks, all sorts of video content. You download that over Wi-Fi, ebooks, of course. You take it home, and you can consume that content at night. This is the flipped classroom model, but there's other ways to explore. And I also see potential in, just bringing that tablet back and giving education to the community, to the parents, right? Adam?
I like to look at the solar container classroom a lot. Do you see that basically existing classrooms, so the stuff that's already there comes redundant, or do they go in places where they weren't schools?
I'm not a fan of bulldozers, right? So if there's an existing building, and a lot of schools have excess buildings, then that's where that's the majority of our work. We've done 103 solar classrooms in Uganda now with the federal government there, and those were all existing buildings that they just freed up. But it's more if we're going into communities where there isn't that infrastructure. There's also one thing we're looking at is in Cameroon for disaster relief. So you have these sort of semi-permanent refugee centers. If we can bring this out as a community ICT center, and though it's based on concrete foundations, it can be removed at a later point.
So these computer classrooms you have established in places where there were no computer classrooms at all.
Yeah, so what we're really doing in Africa, we do some work with nonprofits, and then we do a lot of work with governments. And so usually, in Uganda, for instance, there's a mandate to have ICT classrooms, and in Nigeria it tends to be state government tendered, but tenders will come out. And what we found is that people were just buying traditional PCs, and solar was ludicrously expensive, and everyone just went back to a generator after 6 months. So we tried to integrate the solution, but yeah, almost all the schools we work in, these are the very first computers. Maybe the teachers have used computers before, but that's a maybe, and the students, 100%.
Wonderful work.
Thank you.
Sorry, can you cover security?
Yeah, so it's a good point. Now, Naivasha, this was sort of done outside of the main education system, and actually there was so much excitement in the community that they provided the security. But if someone's armed, they're going to help themselves to what they want. In Nigeria, some of the classrooms we have are actually guarded, 24 hours. But usually for the computer component, what we do is by having this flexible furniture layout, we can move all those computers in, and then we can get by with sort of a metal grate and a bunch of padlocks. There still needs to be some security in place, but the solar panels, by fixing them into the roof, we can also provide additional security, more so than if we retrofit, where they're easier to take. Please? So we've been doing solar. When we launched our first product, our first customer was actually an off-grid solar school in Ecuador, and that was in 2007. And they used our computers for vocational training. So we've been doing a solar classroom in a box solution for almost 7 years. But the container is brand new. I could say I'm launching it at this event. Really, we have a commitment, and we're now beginning the installation phase. But these first 5 are the first 5.
So it doesn't sound as if it's on. Okay, it is on. So what's the impact been on education within the communities that you've worked in?
Yeah, so it's, where we've done existing, it's a great question. I don't know if I'll be able to provide a satisfactory answer. One of the challenges we have is when we're working on government tenders, we're very involved in the hardware and the solar and the installation. But after that, they have e-learning software that they've chosen separately, and they kind of take over the management of it. With the nonprofits, we're much more actively involved. And so we did a lot of interesting work with CamFed in Zambia, in very rural areas. And what we were trying to do there is teach, sort of find girls that could become computer evangelists, that would really geek out on this. And because the places we were working in were offline, and we're going to be offline for some time, we didn't have the distraction of dancing hamsters on YouTube, right? We had a lot more interesting possibilities, and we looked at ways that they could create a local email server, that they could instant message each other locally, so that typing became a bit more of a game, and we sort of taught some of those internet skills, and actually some of those girls are now employed in ICT roles in Lusaka. It's a small number. But one of the most interesting projects we worked on was in Haiti, This is sort of enterprise solar, so tons of money from the Canadian government, big air-conditioned buildings with ridiculous amounts of solar. But what they were trying to do is create a Cisco accreditation lab. And if you have a CCNA accreditation, in the US that will command a six-figure salary. But the process to go through that's very difficult, and you would normally need to have access to hundreds of thousands of dollars of Cisco equipment. But what Cisco's now done is they have emulation software. So we provided PCs, we ran the emulation software. The students learned how to troubleshoot. They gave them some basic switches, but they learned how to troubleshoot this networking technology, and then they were able to fly to Miami to take their CCNA and have a marketable skill and kind of a guaranteed job in government. So, forget learning Office. That's a commodity skill. It's useful, but can we build real ICT capacity? People that could go on to be entrepreneurs and serve small businesses, help them with their own ICT.
Okay, Mike, I think people are needing to get ready for just very,
Yep.
very, yes.
Okay, hello, my name is Munira Twisifu. I work with GEMS Education Solutions on a project in Ghana, one of the projects that he mentioned in his presentation. I think just to add that I find the container classroom model very, very good. And because during our installation process in Ghana, what we found was that most of the classroom infrastructure are such that it's really not possible for you to even put anything in there because the structure is not too good. And even if you ask the community to put up a new structure, they are going to end up with the same kind of structure again.
Yeah.
So I think the
every
container...
time we're reinventing
yes.
the wheel, that's the problem. It's
Yes.
always so ad hoc.
So I think that is a very, very effective solution. And even with the distance learning that you said, apart from the students who are benefiting so much from it, I think even the teachers also, because we get to send lesson plans to the teachers for them to prepare on the lessons. So I think it's a very effective way of really promoting learning. Yeah.
I think, thank you so much, someone who's experienced this firsthand and can be an advocate. So I think, in conclusion, I say, Mike, keep challenging the conventional. It's clearly having huge beneficial outcomes. Thank you again, Irene and the IDP Foundation. I think, they're doing great work, and together she raises the capital, you do the building. So fabulous. Thank you very much indeed.